Assalamualaikum guys. Okay, get yourself a cup of tea or a cup of coffee or get yourself something. Sit tight cause this video and in this session it's going to be a lot of work, pressure, distress, whatever you call it. You need to focus on this one. If you don't know this one, recursion. That's a boring color. Let's pick this. Recursion. We're going to have a long session and this is your last topic for codes. Hopefully this is your last topic for codes. The other topics doesn't involve a code or may involve a code, but basic coding, this is the last one. You may get codes from graphs and trees, but that's the possibility of that is low though. Depends. But for real hardcore coding, this is the last one. So let's go to the topic. So what is this? Recursion actually means a function calling itself. If I tell you what recursion is, a function calling itself would be my answer. So without further delays, let's take you to a simple code. I will show you over here. I have prepared it. So my pencil. So consider this a function, public static int, a return type, factorial, and this will receive a int value. So I have sent 3, and now I have wrote, forget this part, forget this part, don't look at this. I want to find the factorial. So how do you find factorials? If you have 5 factorial, then I'm too lazy to write until 3. Let's make it 3. So if you have 3 factorial, this means 3 into 2 into 1. That is 3 factorial, right? So if I'm sending 3 here, I should make sure that the number n minus 1 or key minus 1 is multiplied with key star key minus 1 star key minus 1 minus 1. So you can say key minus 2, and this goes on. So that's how we're supposed to do this. So here I'm telling, okay, this is the key. So this, let's do some tracing. 111 time, huh? Let's do 3, which is this. I have sent 3 over here, right? So hard. And then this factorial, this is the part which we need to understand. This is the same as this, right? So this among this method, what is the range of this method? This is the range. So inside this method is calling itself. And what is he sending this time? If key is 3 and key minus 1, then that means I'm sending 2. So when I will come back to this method, is the key 1? No. Then I'm sending key minus 1. So this time I had my key was 2. So now 2 minus 1 will be 1. Now when I'm coming back to this method again, and then if key equal to 1, yes, it is 1, so it will return 1. Let me show you clearly. Let's do the tracing from the beginning. So I have 3 over here, huh? 3. You have to understand this. So if key is equal to 1, is it 1? No. So return 1. This option will not work now. Now system out print line, okay, that's for your understanding. Let's skip that. Don't look at this one. So return key, which is now 3. Okay, this is the tracing part. 3 star factorial key minus 1, which is 2. So now we don't have 3, we have 2. Okay, is 2 equal to 1? No. return key, which is 2 star key minus 1, which is 2 minus 1, that is 1. Now we don't have 2 over here, we have 1. If key is equal to 1, okay, this is perfect. Now this works. Now we can enter if. So return 1, that means return 1. So 3 into 2 into 1, what will we get? 6. I hope you understand. I hope you understood this. So let's see the demonstration, right? So it's already compiled, and if you run this, okay, so 3, 2, don't look at this one, this is another method. 3, 2, 6. Why are you seeing this? Because I have set up a system.out.println key so that you can understand. This is for tracing. So for the first time when the method was running, it was 3, and then let's put my pencil again. So it was 3, and then it was not 1. So system.out.println key, which is 3, and that's why you have 3 over here. The proof is this thing. This is the proof. And then return key star, which is 3 star key minus 1, which is 2. And then you have 2. Okay, it should look like a 2. You have 2. Is it 2? Is 2 equal to 1? No. So again, system.out.println 2. That is what you have over here for the tracing. And then return 2 star. So 2 star. And then again key minus 1, 2 minus 1, which is 1. Is key equal to 1? No more calling the method. We didn't say factorial key minus 1 this time, because it will go on forever. So return 1. So the method stops. You only get 1. So 3 into 2 into 1, and that's why it didn't reach else. Otherwise you would have seen 1 over here. But you don't have 1, you have 6, which is actually the first return of 3. 3 star 2 star 1. Now the whole thing returns 6 over here. And since it's a system.out.println 6, it's 6. Now let me give you another thing. If you want to see something for the satisfaction of your heart, then you can see this. So this is the, see, so this 6 is actually the result of this system.out.println. And of course you can also put something else. For example, put 5. Same thing. So 5, 4, 3, 2, 1, and then you get 120. So that's that. Here you can see 120. So that's how recursion of factorial happens. And the case where you stop the function, this case is called the base case. This is where your recursion stops. Now you did notice that recursion is actually a loop. Instead of using for loops or while loops or for array loops and do while loops, all these loops, there are these loops, you can make custom loops. So instead of using these loops, we have a new loop which works as a method, recursion. So you see, recursion is a raw loop. Now we'll see another example. We can't spend much time over here. See this, string length. So here you will send a string, for example, wham. And if this is the base case, if s has nothing left in it, everything is cut off, then return 0. except that return 1 plus. Now if there is something, for example I send nothing, then this method enters an if s equals nothing. Did I send nothing? Yes, I didn't say, not nothing, nothang, I mean null, nothing. Then it will return 0, the string length will be 0. If I even send one letter, then if s equals nothing, no. So 1 plus recursion s dot substring cut off 1. So substring, one string will be cut off and w is cut off. After that this method starts again, and this time there is nothing, so it returns 0. So the string length is 1. So for wham, first we send wam, it's not equal to nothing, so for now this will not work. 1 plus substring length 1, so cut off 1. Now we have am. Is it equal to nothing? No. Again 1. So first there was 1 for w, now there is another one for a. Substring, cut this off. M, is it equal to nothing? No. So what will happen? It will again another 1 plus substring, m is cut off, so there is nothing now. There is nothing. If s equals to nothing, return 0. So 1 plus 0. If you don't understand my Hebrew handwriting, it's something like this: 1 plus 1 plus, oh man, let me just show you. It's 1 plus distance 1 plus distance 1 plus distance 0. Now it looks like a multiplication, this looks like an alpha. Oh, come on. So the string length will be 3. WAM 3. Perfect. See? So I have sent survive CSC. So over here S 1 2 3 4 5 6 7 8 9 10. So my method should print 10, and that's the 10 you saw right here, the 10. So the method is working fine. I'll upload this for you, and there are many other methods. I have codes of arrays, circular arrays, linear arrays. I will upload them before your finals. For now, just you have to it's better to do it on your own. That is the reason I didn't upload the codes. So now that we know what recursion is, we'll just go through some examples. We already did this factorial one, so you know how this happens. Sorry about that. There's a Fibonacci number which you will do just by this. If n equal to 0, you have 0. If n is equal to 1, you have 1, except that you have to put this on your recursion: n minus 1 plus n minus 2. That's all. You did this in your class, so I'm not going to spend some time on this. Okay, these are probably the things that you didn't see in your class. Let's do this. Starting with a linked list. I can't make a list now, it's going to be too lengthy, so let's just go through. So you have a sum that is equal to 0. You have a node that is list.head. So the head is your node. While it doesn't reach null, sum equal to sum plus, which is this, sum plus n dot item. So if the head, let's make a list over here, head 1 and 2. What is the structure of a linked list? 2. This is for 1 and this is for 2. If someone unsubscribes from my channel, I would say this is because of this handwriting. Oh man. So addressing, which is the dot next. Now you have 1 over here, you have 2 over here, you have 3 over here. So don't get confused. This is the address box, this could be the address box. So don't just let this figure confuse you about linked list. So sum equal to sum plus n dot item. N is head now. Look over here. N is head, list dot head. So this is the item. So 1 plus 0 plus 1. Why 0? Sum is 0. Sum is 0. And you have n dot item, which is 1. So this is 1. Okay. N equal to n dot next. N changes. This is 1 now. N dot next. Sum equal to sum plus, which was 1, right? So now that will be plus 2, which is n dot item. And then n dot next. Move on to 3. Sum equal to sum plus n dot item. So 3. That's how it is. So when the first time it happened, your sum was 1. 0 plus 1 equal to 1. And then it was 1 plus 2. So it was 1 plus 2 equal to 3. And then when the last time it ran, sum was 3 and you had 3 on your own. 3 plus 3, which is 6. So that's how you do iterative sum in recursion. No, you don't do it in recursion. This is using a while loop. Now, how do we get this done with recursion? Let's see. Oh, over here. So if list.size is equal to 1, dot size is a method which gives you the size. So if the size reaches 1, return list.head.item. List.head.item. So let me draw those again. Head 1, 2. Okay. Now addressing 1, let's just use 10, 20, 30. Just imagine that this is 30. So let's start this linked list. So I'm sending this head now. If list.size is equal to 1, is it 1 now? No. So that is not the case. Return list.head.item. List.head.item. That is 10. So write 10 over here. Okay. Now this list happens again. So this time over here, who went? 1. Right? List.next, which is 1. So recursive 1. And now over 1, is this size equal to 1? No. So it will go again. And this method 2, 20. So you have 20 plus recursive sum list.next, which is 2. Okay, 2. So now here's 2. Is it list.size, which is now 1? Yes, now the size is 1. It is 1. This is the last one. So just return the item. No more calling the method. So the item is 30, which I told you to imagine. 30. But this time we will not call the function again. Otherwise there will be nothing. There will be an error. So 10 plus 20 plus 30, which will give you 60 at the end. So this was when the first time the method run, this time was the second, and this one was the third. I think by now you already know how recursion works. Let's look at more examples. Here's a bunch of examples you have on your note. We're going to give a quick review for all. We already did this one. This is the string.length. Length of a linked list. Okay, let's have a little look. You will the base case will be L until it reaches null. Of course that will be the base case. So similar to this, H 1 2, and then there's null. So when you reach over here, return 0, and 1 plus list dot length. So 1 plus 1 plus 1 plus, when you reach null, return 0. So 1 plus 1 plus 0, that means 3. That's the length of your linked list. Very simple. Sequential search. Okay, we did the code. Now let's do it recursively. And every single recursion code is as small as a coin. I can't even draw a coin. Okay, let's try again. Small as a coin. I don't know what kind of bacteria is this. Let's just kill it. Anyways, so this search will just send you if it's true or false, if it exists or not. You can send the list, and then there is the key we are searching for. So if L is equal to null, then return false. That means you didn't find it. If you find the item, then return true. You don't have to call the method. And if you don't find it, return contains, which is the name of this method, dot next. So let's do some tracing. Suppose H 1 2 3 A B C D, and I'm looking for C. So key is C, and list A head has been sent. So we are on H. L is equal to null. Is this null? No. L dot item is equal to C. Is the item equal to C? No, it's A. Else return contains L dot next and C. Okay, L dot next. Move on to 1. Is it equal to null? No. Is the item equal? No. Then return contains L dot next. That means 2. We will return 2. We will send 2, and the key is still C. Is it equal to null? No. Is the item equal? Yes. So you will return true. So this true will return back to the method which was 1, and this 1 will return the true back to head. True. And this head will return it back to here. True. So true. This is the first time the method run. This is the second time, and this is the third time the method ran. So this tree returned a true. This true was sent back to 2, and 2 sent back this true to 1, and 1 is the first one which will send back it to the original place. So if you have system.out.println contains, that true will be printed. The next example. This is for an array. So I'll just read this out. If L is greater than L, return false. If the key is equal, then return true. Otherwise, keep moving the index by +1. So this is just equal to L dot next. Same thing, just the same thing. I don't have to spend time over here. Binary search. Keep in mind that for this to work, your array has to be sorted, and it has to be an array in the first place. So the base case is if L is greater than R. So that means when the left one increases, that will not be possible. So if that happens, just return false. Else, find the mid. If k is equal to the mid. Okay, I need to do tracing of this. So for example, consider an array 1 2 5 6. Okay, we are sending this array, and they have themselves. So 1 has 1, 2 has 2, 3 1 1 2 2 3 3 4 4 5 5 and 6 6. Hebrew handwriting, Hebrew. So we are sending this array, and the left is what, starting from 0, and the rightmost is 5, so the index number will be 5. And the item I'm looking for is, say, 55. Is 0 greater than 5? No. So we will not return false. L plus R, 5 plus 0 divided by 2, which will give you, okay, let's put 7 over here to make things easy. So you have 0 plus 5, 0 plus 6 equal to 6. Sorry, 0 plus 5 equal to 6. So k equal to mid equal to this. This will be the perfect mid. If you find the item 44, if k is equal to mid, then return true. Is 44 the item I'm looking for? No. So this case is a no. If k is greater than mid, I told you an array is to be sorted. So 55, is it greater than 44? Yes. So we will do the same binary search, and this time we will send mid plus 1. So 4 plus 1 until 5, and R will be the same, which is 6, and then keep looking until you find this index. So this portion will be searched. Since my array is sorted, I'm sure that it's over here. And if it was 22, then return this same method from the left. So this portion would be where 22 is, because this is a binary search. That means my array is sorted. That's how you do binary search. If you still have problems, let me know. Finding the max. So you have this method called math.max. You can use it to find it, and you can obviously do it recursively by this. Find max, return max, and max rest. So that's how it works. I'm not going to spend time over here. For example, consider that array, and you have 0 to 5. It's not equal, so you'll keep moving 0, L plus 1. So first it will be 0, then it will be 1, then it will be 2, then it will be 3, and there will be a time when it will reach 5, and that is time when you apply the base case and you return. And all the numbers will be compared using math.max. So 0 will be compared with 1, and then this is how it goes. So you will understand that if you see it. Selection sort. Okay, you already know what selection sort is from the last video. So the base case would be if L reaches null or L.next reaches null, then return emptiness. So find minimum node. The idea was to find the value, minimum value. Swap is not a function. This is something we have to make ourselves. Swap is for changing. So you put the minimum value and exchange it with the new maximum value you find. We did selection sort, right? There was 17 and there was 2. So 2 should be here and 17 should be here. That's what swap is. Don't try this. You have to make your swap on your own. And then recursively select sort with the next. And keep iterating the list so that until you reach the end, all the items are sorted. We did this, so we're not going to spend time over here. And this is for arrays, which is even more easier because you can do the swap over here. So I mean, oh no, this is not the array one, this is also the list one. Now it's completely coded, the swap completely coded, and you can just copy this and run to make sure it works. Do the linked list. Create a linked list on your own and try this method. And if it was for an array, let me show you this. Then you will send the array, you send the left, you send the right, and this is the base case. If L reaches something that is more than the right one, and then find minimum index. If you keep, this is for the loop purpose, for looping the function. And swap, I already told you have to do this on your own, and select sort, which has been implemented over here. Complete code. You can try this at home. You are at home probably. Try this now. Put this code and try it yourself. You will understand how it works, because you already know how a selection sort works. Insertion sort. So insertion sort is the array version is shown over here. The base case is same as the selection sort, and you will run it. You have to start from one point and keep moving. If you find someone smaller, then send it to the left. If you find someone bigger, send it to the right. And in this way until you reach the end, E. You have to keep shifting and then sort it out. That's exactly how this works. Instead of having the loop, we are using the same method to do the loop. If you face any problems with this, please let me know, but I think you will not face any problems because the complete code is given over here, and you can use SOP, system.out.println, to do the tracing everywhere. Put SOP, system.out.println, and you will understand how your code is working. That's the best way to do it. Last two, guys. So if you want to find the sum of integers 1 to n, then until you reach 1, obviously that would be the best case, and until then please keep going. More like factorial, except this time you're not multiplying, this time you're adding. So this is not important. This is not important at all. Exponential, you don't have to do this. So okay, now there are some theoretical issues. Let's see what they are. Inefficient recursion. For example, sometimes, okay, I'll have to show you the figure to make you understand this. Infinite recursion. This is very important. This is very important. Ever forgot a base case? Don't do that, because your recursion will go to infinity. Hey, this was beautiful. At least there's something I can draw. So your recursion will reach infinity if you forgot your base case. Now we'll be doing something related to recursion, which is known as memoization. Memoization, I'll keep it very simple, guys. Let me show you something. What memoization is. Over here, we are doing recursion. So this method is working for 4, and this method is working for 3. And then this method is working for 3 again. And this method is working for 2, this method is working for 2. Twice. Again it's working for 2. Twice. So for 3, the same thing will happen. If you get a result of 2 over here, you will do the same over here. If you get a result of 1 over here, you will get a result of 1 over here, and you will get a result of 1 over here. Same thing is running 3 times, for 2 and for 1. 3 is running 2 times. 2 is running 3 times. And 1 is running 1, 2, 3, 4. 4 times. The idea is, if I run this and save it to a value. For example, how should I put this? 43. And you store the answer of this. So let it be 2. Okay, then I can use this over here, and so this method will not run again. You have to understand that every time a method is running, fib, this method is running, it is taking RAM, it is taking time, it is taking using memory, using time, everything. So we have to avoid using the method multiple times. So if it was 100, then maybe 3 will run 1,000, I don't know, maybe 50 or 60 times. That's not necessary. I can just install the value, I can run the method once and then store the value. And for 1, look, it's running 1, 2, 3, 4 times. Is it necessary to run it 4 times? I'll just run it this time and then save the value for 1. And then in here, instead of this, we will run for 1. We will just say, okay, this is for 1. Then I can save a lot of memory and time. Guys, that is called memoization. That's all it is. Perfect recursion, if you want to say. So here they are doing this. They find something, they're saving it. Here, look at this. Compute and save if it's not already completed. So if it is done, something is done, then never done, then it will happen, and if it is done, it will be saved over here. Fib create 1 and it will be stored over here. So if you similar thing is found, then instead of running that method, it will go again. Memoization, you will not face it probably, but I still showed you this. So this is how you do it. There are some steps. I'll just read it out for you. First, write or formulate the recursive definition of the nth number, which is greater than 0, of course. So that's what they have done. If fib n minus 1 plus n minus 2, that's the primary formula. Write the recursive implementation, and this usually follows directly from the recursive definition. This is the general code you will have for this, right? This is normal. This is not the memoization version. And now, after you draw this yourself, now after drawing this, I found out that this is running 1, 2, 3, 4 times. In this way, would this recursion benefit? No. So after this is done, you will understand how to improve this. That's step 3. Then convert your idea to a solution. Lucky for us, the solution is given above. So here you can see they made it out int. There is an array of that new int n plus 1. It will keep adding the table to store computed values, the one you have already completed. F0 equal to 0, F1 equal to 1. So you don't have to run it for F0 and F1. For further values, we'll just keep doing this, and those values will be stored over here. See, this is more perfect that way. And then improving it, the space requirement, and finally getting your method. Just like that, you create those values, you store the values, and then use it for your recursion. Hola, that's all. Memoization is not so important, it's theoretical. So the next item, as you saw just a few seconds ago, is trees. We'll be doing trees, and I have saved the normal recursion codes. You can go to Google and write recursion code examples. Just imagine I'm writing something recursion. Okay, imagine this, I'm writing recursion code examples on Google, and then search it. If you search it, you will find a lot of examples, and there are plenty of examples over here in this note. We did this, right? Plenty of examples for you to work out with. Like I said, use SOP, system.out println, to do tracing of your code. Don't think like this, okay, recursion, there will be one recursion, I will skip that. Don't be like that. You're a CSE student, you are learning computer science. Recursion is a very important skill you must have. So don't be like, okay, I'll skip recursion. No, do recursion, learn it, it's very easy. And try to convert all of your methods into recursion. Once you practice all the examples over here, you will get a good grasp of how recursion works. See? So don't just skip it. Learn it, and inshallah in the next video we'll be covering trees and graphs. And that will be the end of 220 for now. So, see ya and keep surviving. But for today I will say, don't think of surviving. Try to face it. Try to do recursion and win it. See ya.